In this video, we will dive into the Classification Learner app in MATLAB. Our goal is to train models that use our 16 predictor features to classify different types of bins based on those features. To get started, open the Classification Learner app by navigating to the Apps tab at the top of the screen. Click Show More, then find the Machine Learning and Deep Learning section and select Classification Learner. This will open the app. Make sure to maximize it to full screen for better visibility. We'll begin by starting a new session. First, we need to specify our dataset. We will select our training dataset and identify the output variable, which in this case is a class column in the dataset. MATLAB should automatically detect this for you, but it's always good to double-check. Next, we will look at our predictors. These are the features in the dataset, and MATLAB will show us the data type and the value ranges for each predictor. On the top right, we can select our validation scheme. We will choose holdout validation with a 5% split, which means 5% of our training data will be used for validation. Since we've already set aside some test data in previous video, we won't need to separate out any additional test data at this stage. So now let's start our session. Once we start, MATLAB will generate plots that show how our predictors relate to each other and to the class variable. For example, it might plot area versus perimeter for different types of bins, which can give us insights into how the data might separate into different classes. This visualization is really helpful for understanding the relationships within your data. Now let's explore some options in the app. You can start a new session, save your current session, or load a previously saved one, which is handy if you want to come back to your work later. There are also several models available, including decision trees, support vector machines, nearest neighbor classifiers, neural networks, and more. MATLAB automatically starts with a fine tree model. To train this model, simply click Train Selected. This process is quick, and in this case, the model achieved a validation accuracy of 98%. The confusion matrix shows us how well the model is classifying the data. For example, we can see instances where cereal bins are being misclassified as Demerson bins, and vice versa. If you want to quickly compare multiple models, MATLAB offers a Train All option that trains a series of models at once. By pressing Train Selected, MATLAB will train several models, including decision trees, nearest neighbor classifiers. In our case, the cubic kitten performs the best, with a validation accuracy of 92.2%. This suggests that a nearest neighbor algorithm might be well suited for this problem. To further optimize our nearest neighbor model, we can select the Optimize Hyperparameters option. This allows MATLAB to adjust various hyperparameters to find the best configuration. You can choose which parameters to optimize, and under the Feature Selection tab, you can specify whether certain features should be excluded from the model. I'm going to leave all features included for now. The app also offers the option to perform principal component analysis for dimension reduction, but we will skip that for now. The Misclassification tab lets us assign different costs to different types of misclassifications. This can be useful if certain errors are more costly than others. For now, we'll keep all misclassification costs equal. Finally, under the optimizer settings, we see the MATLAB is set to use Bayesian optimization with 30 iterations. Let's bump that up to 100 iterations, allowing MATLAB to train 100 KN models with different hyperparameters using Bayesian optimization. Once everything is set up, we can press Train Selected to start the optimization process. By the end of this process, we will have a more finely tuned model that should perform better on our classification task. Now MATLAB is setting up a series of KN classifiers for us. As we can see, the classification errors across those models were optimized continuously. Towards the end, we did manage to get an improvement in performance. MATLAB found a configuration that gave us a better model. This demonstrates how MATLAB can quickly train and optimize hyperparameters for us. There are also other models available within the Classification Learner app, like deep neural networks, which typically take longer to train. Let's go ahead and try one of these. I'm going to set up a neural network classifier. Instead of optimizing it, which can be time-consuming, I'll just train it with some basic settings. I will choose a neural network with 3 fully connected layers, each with 32 neurons. I'll stick with the ReLU activation function and reduce the number of iterations to 100 to speed things up. I'll keep all other settings at their default values. No feature selection, no PCA, and I'm not adjusting the misclassification cost. Now I'll go ahead and train the model. This shouldn't take long. And here we go. The training is complete. The neural network achieved a validation accuracy of 93%, which actually outperforms our previous models. We can also generate a confusion matrix to visualize the result. Overall, this model looks quite promising. We could dive deeper into the true positive rates to identify which classes are being mispredicted as false positives or negatives. At this point, we could export our neural network classifier to the workspace for further use. But before we do that, I want to show you the Costs tab, where we can set the costs of different misclassifications. Let's go back to our best KN model, which was a coarse KN. I will duplicate this model, creating an untrained copy, and then go to the Cost tab. Now I would like to see the previous confusion matrix, so I will click on it and open it up. We can now adjust the misclassification costs. For instance, imagine you are dealing with 2 types of beans, the Sierra bean, which is poisonous, and the Dermazine bean, which is not. We definitely want to avoid classifying a Sierra bean as a Dermazine bean, as this could be dangerous. So to minimize this risk, we will increase the cost of misclassifying a Sierra bean as a Dermazine bean by a factor of 10. On the other hand, we don't mind as much if a Dermazine bean is mistakenly classified as a Sierra bean. So we will lower the cost of that misclassification. After applying these changes, we can see that MATLAB now uses a custom cost matrix. So train selected. As expected, applying this cost matrix leads to a decrease in validation accuracy because the model is now biased to error. If we look at the confusion matrix, we see that only one Sierra bean was misclassified as a Dermazine bean, but many Dermazine beans were predicted to be Sierra beans. This trade-off means our model is now more cautious, prioritizing safety over accuracy, which is exactly what we want in this scenario. Comparing this to our original core-scaling model, we had 16 misclassifications of Sierra bean as damascens, and you can see how adjusting this causal matrix can significantly influence the model's behavior. That's all I wanted to show you from the Classification Learner app. In the next video, I'll show you how to export the trained model for further use. Thanks for watching.